To learn more about earning college credits with study hall courses, visit gostudyhall.com or click the link in the description. A surprisingly time-consuming part of being human is doing the same things over and over, like washing dishes, doing laundry, or deciding on yet another hobby I'm going to spend way too much time and money on. Okay, that last one is pretty fun, not gonna lie. And programming, as we've been exploring throughout this video series, has a bunch of clever problem-solving tools that save us time and effort. Unfortunately, this computer won't do my laundry for me, right? But it can deal with lots of data. In fact, when it comes to doing the same thing, or something very similar again and again with data, there's a piece of code tailor-made for the job. The while loop. While loops let us use the power of computers to repeat a task exactly as many times as we want, breaking us out of the endless monotony. I'm Sabrina Cruz, and this is Study Hall, Code and Programming for Beginners. Before we get into while loops, let's loop back to some of the other ways we've explored that reuse or repeat pieces of code. That'll help us understand what loops add to our Java toolkit and what they accomplish for us. First up, we have methods, which are ways of calling on some block of code to execute in different situations. Like, you could have a method that takes two numbers and prints out whichever one's bigger. We can call this method, which will repeat the actions of that code every single time we want to compare two numbers. And secondly, if a big problem we're trying to solve has a bunch of smaller, similar tasks, we can also turn a method into a self-repeating cycle. The idea is that every time you call the method, it executes some code that includes calling itself. This whole put the thing inside the thing itself, like a method call inside of a method, is the classic hallmark of recursion. Compared to recursive method calls, a loop is generally much simpler. A loop lets us repeat a block of statements in our program without having to retype any of the actual code or explicitly define and call a method, which is more work, and I am very lazy. The block of statements in a loop is usually some kind of action we want to execute again and again in sequence with different bits of data. And when a loop is done, our program moves on. We don't usually call on or go back to that loop later. For instance, we might have a statement that adds a whole bunch of numbers in a sequence, one that removes the hyphens in a list of phone numbers, or one that changes pixels to blur out a license plate. All of these can be implemented in a loop. There are different kinds of loops, and the while loop specifically executes some block of code again and again while some condition within our code is true. If that last bit sounds familiar, it's because a while loop is really similar to an if statement. In fact, while loops use the same rules of computer decision-making with conditional logic expressions that evaluate to true or false. To see how and to get some practice with the basic mechanics of a while loop, let's look at a simple example that just counts up from 1 to 5. First, we'll define an integer variable called count with a starting value of 1. Next up comes the structure of our while loop. We start with the word while, followed by a conditional statement, or condition inside of some parentheses. And then, just like an if statement, everything in the curly brackets that follow will only execute while the condition in the parentheses is true. Given that we only want to count up to 5, our condition will be that our count variable is strictly less than 6. As for the bit inside of the curly brackets, all we want to do is print out the current integer assigned to the count variable, and then add 1 to it, so the value increases every time the loop runs. If we run this, what do you know? We get the numbers 1 to 5. Good job, computer! To see what's going on under the hood when this Java program runs, the first time the while loop executes, the code evaluates the conditional statement inside of the parentheses and determines, yep, that count variable is 1, which is definitely less than 6, so the condition must be true. And because the condition is true, the loop body executes. So the program prints the count, which is 1, then the value of the count variable is increased by 1, so now it's 2. Finally, the computer checks the loop condition again to see if it's still true. Because 2 is still less than 6, the code block runs again, and this general process will keep going, or looping, if you will, until after the 5th time comes around. At that point, our count variable hits the value 6, so when the condition is evaluated again, it's false, because 6 isn't less than 6. The while loop breaks and stops running everything inside of the curly brackets. But just because our while loop is done, our code doesn't stop altogether. We could put in some more code after the while loop to expand on our program and give the computer something else to do next. Even though counting numbers isn't all that exciting in the grand scheme of problems to solve in the world, knowing how to use while loops is incredibly useful. For instance, let's head over to Amira, an avid record collector who saves a little money every month so she can splurge on some new purchases. Amira has an ongoing list of records she wants to buy, all with different prices in a specific order that reflects her current tastes. And every month, she works out how many she can afford by adding up the total cost of each record on her list in order until it exceeds the budget she has for that month. Until now, she's been scribbling on scraps of paper and fiddling around with a calculator, but there is an easier way. Using her knowledge of while loops, she can write a Java program. She starts with some key variables. First, she'll create a double variable to represent her budget for the month, and another double variable called cost, which will be the cost of the first record she wants to buy. Both of these values will be user inputs thanks to the scanner. Next up comes an integer variable representing the total number of records she'll be able to afford, and a double representing the total cost of her record selections so far. Both of these variables are initially set to 0, since the purpose of the program is to add up the possible records that fit under a budget. Now the stage is set for the ingenious while loop. Inside of the loop, Amira's code adds the cost of the most recent record she inputted to the total cost so far, and increases the number of records she can afford by 1. Then she inputs the cost of the next record she wants to buy with the scanner. All in all, the while loop in her code keeps a running total of the cost of her chosen records and how many she can afford. But how can she avoid going over budget? That's where the conditional statement of the while loop comes in. Her condition states that the total cost of her selected records so far, plus the cost of the next record she wants to buy, can't be more than her budget for the month. So the very first time her while loop runs, it'll check whether she can afford the first record, whose cost was defined outside of the loop. If that record costs more than her whole budget, the loop never even starts. Sadly, she won't be buying anything that month. Very relatable, Amira. It's tough out here having expensive hobbies. But if that first record costs less than her whole budget, the while loop increases the number of records she can buy by 1, and lets her input the cost of the next record on her list. Then the while loop evaluates the condition again to check if she's over budget. If not, the loop runs again. But as soon as the total cost variable, plus the cost of the last record she puts in, exceeds the value of her budget, the loop breaks, and the program moves on past the while loop to let her know how many records she can afford. Let's test it out. Amira executes her code and inputs her budget for the month, which is $106. She then enters $12 as the price of the first record she wants to buy. 12 is comfortably less than 106, so the while loop begins to run. As the loop starts looping, she adds a record that costs $19, another that costs $13, then another that's $45, $7, and then $13 again. And look, her total cost plus the cost of that $13 record she just inputted comes to $109, which is more than her budget, so the while loop breaks, and the code that follows after the loop tells her that she can only afford 5 records this month. The real magic here is that Amira never has to explicitly set her loop to execute a certain number of times. After all, she doesn't know how many times she can add a record off her list and stay under budget. That's why she needed a program. Instead, the condition inside the while loop handles it all for her, adapting to the logic that changes as her code executes. For instance, if she gave record prices of $70, $20, and $16, her code would have told her that she could only afford 3 records. But a bunch of bargain bin $2 records would have kept that while loop looping many more times. It's moments like these that code really shines. By combining the number crunching power of computers with their capacity to follow logical conditions, programming can automate our decision-making processes. Of course, we humans are still the ones setting out what those logical conditions should be. To create her code, Amira had to capture the essence of her problem in the condition of her while loop, namely her budget constraints. So it's important to practice distilling the nuances of real-world problems into logic that a computer can understand. Because once we can do that, we can really dig into the tools of programming, like while loops and their adaptive code-repeating powers. If you're enjoying Study Hall Code and Programming for Beginners and are interested in taking an online course and earning college credit, visit gostudyhall.com or click on the button to learn more. Thanks for watching, and see you next time.